hope you can hear me well. My name is Emin. I'm really pleased to be here at stage, and I'd like to tell you a story. Because when you choose a technology for your product, there are lots of decisions to make, lots of tools, libraries, and frameworks to choose from. And most of those tools will have technical documentation, tutorials, describing in detail how to use them. Most of them will also boast a number of great companies who use those same tools and frameworks to build their apps. But what's missing quite often is a story not from Apples and Facebooks and Googles of the world, not from the companies that have endless resources. They can put a lot of money and a big team of people to develop anything they want in any language they want. A story from a company that is similar to you, that has few team members, that is tight on budget, that has strict deadlines, and that really needs to make a right decision. A story that can actually convince that kind of companies that this is a tool, this is something that could help them. So this is the kind of story I'd like to talk about, and hopefully for some of you it will be exactly what you need to convince yourself that if we were able to do it, then you can pull it off as well. With that, I'll just give a quick background of who I am, where I come from, and how we arrived at the decision to use this technology stack, and then we'll go in detail in describing how we actually did it. So I live in Azerbaijan. It's a small post-Soviet country, as I said. It's about 4 times smaller than Germany by area, about 8 times smaller by population. So it's a relatively small country, a little less green as well, as you can see. And like most post-Soviet countries, we went from having almost no technology in late 90s to a lot of technology in the last 10 to 15 years. And especially after oil money started flowing in, there is all sorts of gadgets, ubiquitous high-speed internet, 3G, 100% coverage of 3G across the country, now 4G, people adopting smartphone revolution, using all of those apps, Facebook, Instagram, YouTube, Google+, well, maybe not this one. And with that, adoption of global services started to grow as well. So of using services, actual services, not just consuming content. And local services started developing on top of that growth. And we have found ourselves at the forefront of that in the last few years because we run a classified website in our country, and you may have heard, depending on where you come from, either Craigslist, OLX, or Avito. And this is our website, and you have used any of those websites, you know what it is. Basically, it gives you a way to buy and sell stuff online. And as I said, there is this big growth in internet users coming, and we are at the forefront of it. And when we started this project, we went through, in the last 18 months prior to that, from 300,000 monthly users to 1.5 million monthly users. And but we still have this very limited team, very limited resources and small team, so we have to pick our battles. We have to decide what to focus on, what to develop next, how to grow the product. And the reason I mentioned this technology growth, rapid shift to new technologies, and what happens in those cases, you skip over a few generations. So I think we were ahead of the global trend of everyone moving mobile. For the last few years, almost all of the sites in the country have more than 70% of users for mobile, and we certainly see the same pattern on our websites. And for quite a long time, we've been serving all of those. We've been serving mobile website to all of those users, and it was fine. We have a desktop website for desktop users, mobile website for mobile users. It's fast, it loads quickly, it gives you the full access to full features, and we really focused on that. But after some point, as you grow, we started to realize that as more people get used to having an app on their device, an icon that they can click, they want you to have that too. They actually expect you to have two. They demand you to have an app, and get disappointed, say, why don't you have an app? And as we were approaching a million monthly users, we decided that, okay, we got to a stage where we actually have to do something about this whole mobile app thing. And but more importantly, one more important point, apart from customers being unhappy, it leaves a space for competition to come in and hit you in the weakest spot, develop an app, and start to compete with you in this field. So we decided that since, as I said, we have to pick our battles, we really have, if we are going to do this mobile app thing, we have to, it has to meet certain criteria for us to be able to do it. And criteria were simple. I mean, everyone wants to be able to launch and iterate quickly. But for us, it was even more important because we didn't want to build separate iOS and Android team. We didn't have anyone on the team before that who built any mobile apps at all. No one knew Objective-C, no one knew Java, at least in the context of Android development. And not only did we not want to add new languages to our toolkit, we also wanted to avoid having multiple code bases to support, because make no mistake, iOS, Android, mobile website, desktop website, those are different products. Even though they may end up serving the same need, you have to actually support them separately. You have to coordinate deployment of the features. You have to test them all separately. So the more different code bases you have, the difficult this task is. So we wanted to have that, but at the same time, we wanted to have some access to native features, and we wanted to get that fluidity and feel of the native app. And so that brings you, that limits the number of options you have. And basically, if you decide to develop an app, between having a website and having a properly 100% native app, there are all sorts of different hybrid apps. And I won't go too much into semantics, but basically anything that's not a website and not 100% native, I call hybrid. And it's impossible to choose from all of those alternatives, so we had to choose a specific points on this range, and what we wanted to do is to get as much possible to the right side without actually going native. And basically it was 3 options from starting from the easiest one to, well, I'll talk about that. So the simplest thing you can do, and it doesn't conform to all of our criteria that we had, is just to make a website wrapper. Just call it a day, launch it, and you have something already working for customers. And it is really quick to do. You get exactly 100% code share between all of your platforms. And if it already works for you on mobile, why can't it work as an app? And it turns out that expectations are different, and people who access your website and access your app, if they get exactly the same service, the perceived service will be worse on mobile app because the expectations are so much higher. But yet, this is not to be underestimated. For instance, looking back, I'm thinking that maybe we should have started with this while we were developing a native app, to start collecting audience, because it gives you 2 things. First, it gives you discoverability, and for many people, they just open App Store, they type it in, and they don't find you, and they off to another thing, or maybe they find a competitor and use them instead. And also it gives them a quick access to your service by having a screen icon on the screen. And you can say, oh, okay, this can still put a shortcut to the website on the screen, but then they can't. I mean, for us, it's geeks, it's like normal thing to do, we can do anything we want. Normal people don't know where Google starts and browser ends, what's the difference between Wi-Fi and internet, so let alone being able to install a shortcut. So it's not to be underestimated. It's a good step to do if you really want to start something, but you ought to have a plan to develop it, otherwise you will keep getting not too good reviews. Some option in between for us was going semi-native, because we use Ruby on Rails on the backend, and folks from Basecamp developed this product called TurboLinks, which allows you to have a native shell, so you have a native code where it's important, and you use web use for everything else. So it's sort of like previous option, but on steroids. And it's a very good option if you have many screens like they do. For instance, if you have 100 screens, 200 screens, I think they have different screens, you don't want to implement them all on your app, then this is the way to go. You implement the common shell, navigation, maybe important performance-sensitive part of your app. Everything else is WebView. And the drawback for us is that you still need to know Objective-C and Java to develop those shells. However minimal, it's still, you need to know that. But also, the performance, despite the fact that it's much better than in the first case, it's still not up to speed, not on the same level as a native. So which brought us to really the third option, going almost native. And again, even with this niche, there are a bunch of tools, bunch of libraries that you can use. I'll be honest, I haven't tried most of them because we had already experience with React on the web. It worked well for us. We looked at that we can use the same tools, the same language that we already know, and we get almost native app. It's native. I'll talk about why it's almost native later, but basically we get almost everything that we want, and we get to use the same language and the same code base across two platforms. So React Native, and if you haven't used it before, it's a way to define your UI in terms of native components from within JavaScript. So you orchestrate all of the interaction with in JavaScript, but the actual components themselves are native.
And we saw that it's got a good story on both Android and iOS, and it's got a good ecosystem. And we already know new React before from our web experience. So we decided to get started and see where it takes us. And the great thing about React is React Native is how easy it is to get started. Assuming you have all of the dependencies installed, it takes 5 minutes and these 4 simple commands to have something up and running. Granted, it's a simple thing, and you can say, well, big deal. But it is actually a big deal. The reason it is a big deal is because it's extremely satisfying to get something on the screen, on your screen, without knowing anything about mobile app development. I certainly was really excited, because for me it was like a whole new world. I don't know anything about it. Haven't ever touched Xcode, not Android Studio. I don't know how to configure whatever needs. I don't know the build pipeline. Yet I'm already having something on my device up and running. I can edit my JavaScript file. I can change how it looks. So this short feedback loop, it's almost reminded me how 20 years ago when all this was starting, we have active server pages, if anyone remembers them. You have small Visual Basic script, and you create a loop, and you generate HTML, and wow, you have something running on the server. So it sort of reminded me that, because I knew nothing at the time, and then I already have something, and it was the same feeling. And this is what you get when that's a file that you get after running all of this, that command. There are a number of dependencies and configuration files, but this is the essence. This is your JS file. And as you can see, it's pretty readable even if you haven't touched any of React Native, any of mobile web development before. You got a bunch of imports. You've got something resembling style sheets. And you've got in the middle, you've got a component that defines a view which contains a text and some styles applied to it. And almost anyone who has done any programming in JavaScript will be able to start working with this immediately. Now, you will notice that you still have this view and text components, which are native components. So despite the fact that, as I said, you're running it from JavaScript, what you render on the device is a native view component, which contains native text component. So you still have to learn that part, obviously. You still have to learn what are the different components available, what is list view, what is scroll view, how to put an image. But this is expected, because after all, this is exactly what we wanted. We wanted a native app. And this is sort of cool that you can do that. You can do that so quickly. But also, it's JavaScript, right? And I don't know about you, but after using Ruby on the back end, after using Clojure, I don't enjoy working with JavaScript at all. It's got all of those quirks and whats and lack of standard library and all sorts of issues. And we really didn't want to develop in JavaScript as a language. So we liked React Native as a platform, but not the language. But if you think about it, we already had the same problem on the web when we've been adapting React. And we used it together with Clojurescript. And it worked fine for us. So we thought, why not try it here? Why not see? Maybe we can do the same here. So Clojurescript, I don't think this crowd needs much preaching of the benefits of the Clojure as a language. At the same time, I think Clojurescript as a platform still faces some skepticism. Yes, its adoption grows as state of Clojure shows, but still compared to the size of the JavaScript as a host platform to the JVM, it should be much more popular before we can say it reached the same level of adoption. And a lot of that was because it came later. It had some sort of difficult tooling in between, in the beginning. The REPL, there were some issues with launching REPLs and things, but things have significantly improved. And then this mobile app thing comes. React Native itself is relatively new, has all sorts of edge cases that you need to manage. So you normally, it's expected that you would be concerned about using it with Clojurescript. So we were not sure, so we decided that we should actually just try it and see if it works for us. And that's what we're going to be talking right now about. And by the way, if you yourself are not yet sold on Clojurescript, I highly recommend this talk. It was given a couple of years ago on ClojureConf. And it's even better now because a number of drawbacks that have been mentioned in that talk have already been addressed since. And even if you are convinced, it may help you to convince your colleagues to adopt Clojurescript. Speaking of improvements, if you're not following, Clojurescript.org has some news regarding recent developments. A lot of new things are coming, so I suggest you read that. So the biggest benefit that using Clojurescript for mobile apps is it's an extension of having the same language across your whole stack. We are not there yet ourselves, but we have this ability: Clojure on the backend, Clojurescript on the browser, Clojurescript on for mobile apps. And I think it's great, and this is something that should be considered when evaluating your options. So on the web, we use this library called Reagent, and if you haven't used it before, it's a very minimalistic layer on top of React, which allows you to define, instead of using JSX, instead of using some JavaScript-specific constructs, you just work with functions and data structures to define your UI. And you have these atoms that are observable, and by updating that atom, you force the rendering of your interface. So let's look at the simplest component that you can have that's straight from the Reagent for the web, Reagent documentation. As you can see, it's just a function that returns a vector. It returns vector. Yes, it got some additional attributes to define CSS, classes, and IDs. But basically, I think everyone can immediately understand the HTML that it will render to. So it's a div with some text in it and a couple of formatting pieces. And this is a common theme. I think this is what Rishik is always saying. So it's much better to have a limited set of data structures and a lot of functions working on it. So this works with that paradigm. Just have a simple function, and that returns a data structure. So let's look at the more involved example. And this is a pattern that you adopt in almost all of the Reagent applications. You have an atom. In this case, it's a global atom. It's usually a global atom that holds your app state. It defines how your apps looks. In this case, it's just a simple click counter, just holds an integer. And notice it's not a regular atom, it's a Reagent atom. So what it does, it tracks all of the updates to this atom and renders all of the components that derive this atom. So if you look down, this is a component itself. It derives the atom. It shows you the actual click count. And it's got this button with a function attached to its onClick event. And what this function does, it increases the value in this atom. And because this very component derives this atom, you immediately see the result. And this is a very simple concept. I'm only describing in case for those who haven't seen it before. But it turns out, interestingly, that this is conceptually everything you need to know to start working with Clojurescript and React Native. So let's see how it's done. Let's see how it's done in Clojurescript World. Again, assuming you have all of the dependencies installed, just for commands, and you're up and running again. But it's a Clojurescript version now. So instead of just JavaScript, it pulls in all of the dependencies that you need, sets you up with a framework. It could be Reagent, it could be Omnext, it could be some other wrappers around React. Because we used Reagent, we kept using it. But it could be other frameworks as well. And Renatal, which we use, it does all of the heavy lifting behind the scenes to get you up and running. And again, in 5 minutes, you have something running on your device. As you can see, it's more advanced. That's plain React Native version. And it comes with BigWill. So if ever any of you have used BigWill, it gives you the ability to do a hot code reload. So you can change the file, and before you turn your eyes to your device or to emulator, you already see it's updated. Even on a large app, relatively large app, our app isn't that large, you get sub-second delay between saving file and seeing it reflected. And if you do it properly, you maintain the current state of the app, so you don't have to repeat any of the steps that you did before. Again, what it gave me is a confidence. Actually, once I ran those 4 commands and saw this for the first time, tried to load a few more native components, this gave me the confidence that we can actually do it. That despite the fact that we don't have much experience, we can actually do it. And this was a sort of liberating experience. It's like something I just somehow felt relieved that it may not be that difficult after all, given all of the work that have been done with these tools. And so just to compare the output, I dumped it down a little bit to the standard version. This is a version that you will get in Clojurescript version. And as you can see, it's also a bunch of imports and ders, but the big difference is style sheet isn't an object anymore, it's just a map, just a data structure. And the component itself, again, just like in React, in Reagent for the web version, is just a vector. The only difference is instead of returning paragraphs and divs, you are now working with those same native components like view and text and a few hundred others that you will need to know about if you want to use them in your app. But the biggest benefit that you get is you can use all of the power of your programming language to manipulate those data structures instead of working with a custom objects with a custom behavior. So for instance, if we compare that specific piece, so on the JavaScript side, you have this class that extends as a class that has render function, which returns JSX, which basically, and if you have to wrap your head around it in Clojurescript World, it's just a function and a data structure. That's it. Now, I think for us, it was sort of simple made easy moment when we realized that we could actually use this beautiful, simple language to develop and manipulate our mobile app with ease. So sort of a manifestation of the concept. And if you haven't watched this talk at least 3 times, I highly recommend you do. I think I watched it 5 or 6 times. Maybe I'm slow to understand, I don't know. But I think it's a great talk. And that, as I said, so we have this sort of a manifestation of that in what we developed. So I'll show, so I wanted to show a quick demo, but before I do, so we decided we built a prototype. We built a prototype that had some very basic functionality, and we decided, yes, this is workable. So we hired a full-time engineer to work on this. It was just one developer. And after 3 months of work, including the work to design, do the mockups, to develop backend API, do all sorts of integration, going through testing, fixing the bugs. So after 3 times, we launched our first version in production. And it has got no native code at all, except some configuration, which isn't code. And you just add a couple of libraries, configure them, very minor touches, and everything else is in pure Clojurescript. And this is what we were able to develop in 3 months. I hope it plays. So it's a kind of app. So you've got endless scroll of listing. You've got search, filtering. You've got per category fields, detailed view, photo galleries, zooms, bookmarks, swipe to back on both iOS and Android. You've got native share buttons. You can post your own things. It supports multiple language, so we've got the localization built in. So it may not be that basic after all, but clearly not a base camp either. But the important part that I want kind of to stress on here is regardless of how simple your app is, the important part is how well it works, how fast it is, how fluid it was, how easy to support it is. And I hope that demo gives a sense of how it works, and it is indeed something very similar to what you would have built with a native app. And so if there is one takeaway that I want to share, so that I want others to take from this talk, is you can actually do that. If we were able to do that, you can do that too. And yes, it's not a painless process. Yes, you've got a lot of things to learn along the way, but it may not be not nearly as difficult as if you would be doing the same thing from the scratch in native language. So Obviously, I can't go in detail to describe how we've done everything that we have done, but I will kind of focus on 2 examples, because some of you may ask, so why did it even take you 3 months if it's so easy and straightforward? And in a way, you would be right, because first version of this product was developed in a month. So conceptually, it had all of this most of this functionality. What takes the other 2 months to develop is ironing out all of the small issues. And this is what differentiates bad applications from good applications, is the amount of effort you put into little details, starting from when you do swipe to back, when it should react, at which position it should react, ending with how well your gallery works on multiple devices and multiple sizes. Did you do enough testing? So all sorts of small things that you have to take care about and when you develop. So I'll just give 2 examples that I think I'm on the right screen. Yes. I'll just give 2 examples. So one example is on the left side, you see here the listing of products. When you click on it, it opens up the detailed view. And I hope you have seen it through the demo, that it's fluid and it works immediately. So quite often what I see, and what I'm going to say isn't rocket science, I'm only talking about that because I see it so many times, I've seen it in a real apps. Maybe this is because when you develop on your local website, on your local machine, or on the high-speed internet, the response is so quick that you don't notice it. But what happens is when you click, you would fire a request, you get a JSON back, and then you render your result. And it may be fine, it works, right? But we can do much better. Because if we look at it carefully, on this screen, we already have a product name, we already have a price, we already have a city, we already have some other data, and we already have a picture. This same data is available over here. And instead of firing a request, waiting for it to come back, you can already show something. You can already, while it will take time to process for the customers or what they're seeing, you will already have received the remaining pieces that were not available there. And it's so easy to do in React, because everything that defines your application is in your state. So if you populate this state with partial information, it will render that partial information. You don't need to do custom logic. You just populate what you have, and then you request the missing pieces. And that would work, but we can go even better. We can do even better. Because if you look again at this screen, it's got very little additional information, just a few lines of text, contact number, maybe links to all of the images, basically just a few hundreds bytes, maybe a couple of kilobytes per listing. And it's not much. And there is nothing stopping you from sending this information along when you send the whole list of products, which allows you to immediately render the second screen with all of the data available. Now, you might ask, but that means I need to send more data. Yes, you do. But the payload difference is, especially after you zip it, is so negligible that, and the experience is so much better that I think it's a good compromise. At the same time, if your payload is really big, what you can do is to load all of the things that are visible above default, that are visible once you load the screen, and load everything else after that. We actually do a little bit of that. So, for instance, we don't load related products. We don't load some other data that's below the screen until you actually go to the page. But you never notice that, because by the time you scroll down, it's already there. And second example is similar conceptually. So you have this list of categories. When you click it, you've got a list of subcategories. In each subcategory, there is a list of additional fields, a few hundred different variations. And again, what's quite often I can see is you click on it, it loads up the next level of the tree. You click again, it loads up the next level of the tree. But if you look at the whole tree, it's just 20, 30 kilobytes of data before you zip it. So again, nothing stops you. And you only need to do it once. You only need to do it synchronously, if you like. Only do it when the first time a user launches an app. You load those 20 kilobytes of the information, and then you only update it in the background. And what it gives you is for the user, it's always up to date. It always has got this fluid experience, and they don't need to wait. And for you, what it gives is always up-to-date data. Yes, it may be changing like once an hour, but for this use case specifically, it was more than enough. And again, this might be obvious for many of you here, but because it so often isn't done, I decided to talk about it. So with that, we built our app. It's working, but it's not enough. It's just one part of the equation, because you also need to send data along from your backend API. And you may say you can use JSON, and you would be right, you can do that. But JSON is good. Its spec is tiny, which is easy to understand, but also it's got a lot of limitations. And if you have tried to pass dates or sets over the JSON, you will know what I mean. And the transit format is sort of like Clojure and Clojurescript. It's hosted format, if you can say it this way. So it works on top of JSON and message pack. And it gives you all of the benefits without all of the drawbacks. So you can use, suppose any data types, many built-in. If some of the data types are not supported, you can do custom parsers and custom writers for them. And you can use arbitrary keys, not just string. And it's really language agnostic. There are official implementations in a bunch of languages, and there are unofficial implementations for most other languages. So for instance, you can use it to power your Angular app working with a Django backend. So you can do that. Nothing stops you from doing that. And it also has got compression and caching for performance. And somehow reading everything that's happening on the Twitter and internet, I get a feeling that not enough people appreciate the benefits of transit. So I've thought I'll put it here, because that's what we're using to communicate between our Ruby backend and Clojurescript application. And again, sometimes what's missing is the silly examples. And this is an example of the map, the hash in Ruby. And it's got this keyword, what we call it's a symbol in Ruby, it's keyword in Clojure. So if you were to send this map over JSON, you cannot use symbols as, you have to use strings as a keyword, as a keys to the map. But then you lose that ability to work with idiomatic Ruby and Clojure. So you either have to custom encode it somehow to be able to read back the readback symbol as a keyword, or you just use transit and it does it for you transparently. So for us, it was very, very useful, because we like to use symbols and we like to use keywords, and transit gives us this opportunity, so we don't need to downgrade to lowest common denominator. And I recommend using transit everywhere where you now use JSON. I think it's so much comfort, and it's very easy to do. Again, you import a couple of libraries, you do some additional work to generate these files, but that's it. Everything else from that point forward works transparently. So we have an app, we have an API, we have it working, but then there comes time when you need to ship updates. And one of the criteria, if you remember in the beginning, was for us to be able to iterate quickly, because we are so used for that in the web world. You just commit, you deploy, and voila, everyone's got latest version. You can't get that level of interactivity yet here, but you can get very close. Especially that sending updates in a normal native app world is quite an experience. If you haven't tried working with Apple App Store, you will again know what I mean. Google's is much better, but still kind of lots of hurdles to do. Apple has also to review your app. It takes now 3 days. It used to be 3 weeks. So much better, but still you have to go through that process. They also lose all reviews, because by default, they only show you reviews for the latest version. So because of all of those reasons, what happens is developers tend to accumulate changes and push them every few months, which results in a slow iteration. But most updates don't require you to change binaries, because if we had a website wrapper, anytime we would update our JavaScript and HTML, we would get a new version. Everyone would get a new version. But this is also JavaScript. This is also can be updated from the internet, and there are some services that allow you to do that. And one of those services is called Code Push from Microsoft, by the way. So you register and integrate SDK, and then you push updates to the server, and then on an application, you can download it in the background. You can download the background and apply when it's convenient. When we started, we did it in a really stupid way. We applied update immediately, so user would be in the middle of the flow, and boom, it would reload. So now we are more careful. We download it. We wait for either period of inactivity of 50 minutes, or if application is exited, and on the next launch, you would just get a new version. And most features that you deploy, most features that you change are like that. It's either a bug fix, it's a layout change, it's some small update to some small section. So obviously, if you update React Native, if you want to ask for new permissions, if you want to do any sort or integrate some native library, you have to go through the App Store. But that is relatively rare. And you can bundle all of your ongoing updates that you have done through code push with those sorts of updates. And also, it allows you to roll back. So just for my commands, you can list your deployments. You can see the adoption, like 70% adopted new version. And if in case you see exceptions going through the roof, you can roll back quickly. So it gives you a very easy way to manipulate your deployments. So let's see what the results. So that kind of brings me to the end of the presentation. Just wanted to share the results. So we built an app. We created an API. We developed we used a way to update the app. And we launched it about a year ago with supporting iOS 8 and Android 4.1 and higher. We got now almost 200,000 installs. We've got about 20% of the daily sessions from the app and 99.8 crash-free sessions on both platforms. And when we started, it was the first beta, it was 80%. So it took some work to bring it to 99% and then to 99.8. Now, it sounds like a small difference, but it's actually 8 times more reliable than 99%. So, well, 5 times, sorry. My math is off. I wanted, so average rating is above 4.7. Granted, part of it is because of the service itself. Hopefully, it's good. But it's also because it allows people to actually do what they need to do in a comfortable way. And speaking of reviews, there was one review that I will share in the end. It says, I didn't like the app, but I'll give you 5 stars for the effort. That was a very interesting review. So not very often your customers appreciate the effort that you have put in. So thank you, anonymous reviewer, and thank you, dear audience, for listening.